Hi, my name is Jose Ochoa.
My name is Abrahm Lema.
My name is Hoaglan, and this is our motorized skateboard with LCD speedometer that we created for our ME106 term project. We used a brushless DC motor. I was in charge of the drivetrain for this project. I chose a brushless DC motor for its very high power output in a compact package. This is one straight from an RC airplane, hobby grade bender. Same thing in the electronic speed control down here. It's also a hobby grade electronic speed control from a RC airplane, 60 amp speed control, and then a 5-cell lithium polymer battery also of the same spec. The motor is claimed to be 1190 watts at 20 volts and like 53 amps. The drivetrain, I fabricated the L bracket here that attaches the motor to the skateboard truck, and I fabricated the hardware that interfaces the pulley on the wheel to the motor pulley. I was a drivetrain tech, and this is how I finished it. So here's Abraham, who did the speedometer.
Alright, so my contribution to this work was working on the speedometer. So basically we use LCD, which is liquid crystal display, and the main part is on this side. So this LCD display has 16 pins, and the first two pins are the power supply pins, which is ground, and it's on this side. These first two pins are ground and supply voltage. The third one is pin for the contrast of the LCD display. The fourth and fifth pin are either data or common pins, and pin number 10, 11, pin number 11, 12, 13 and 14 are the messenger pins. What they do is they transfer information from the Arduino microcontroller to the LCD display, and pin number 15 and 16 are the power supply for the backlight of the LCD. So what we did was we put medium magnet into one of these wheels, as you can see here, and there is a Hall effect sensor behind it. So what the Hall effect sensor does is whenever it gets to the medium magnet, it will sense a magnetic field and will send a message to the Arduino microcontroller board. And by using the messenger pins, which are pin number 11 to 14, will send communication into LCD display, and it will show the user the RPM and MPH of the skateboard. And by doing this project, I have learned that how to apply the knowledge that we have learned during the lab, which is the stepper motor. Even though I didn't put any kind of work on the motor part, I was able to understand how to manipulate motor programs into actual motor device. Also, the LCD display laboratory, if I'm not mistaken, lab number 4 or 5, was very helpful. And the other thing I have learned and will apply on my future classes is that starting project on time and as early as possible is very helpful. And I'm gonna transfer this to Jose.
So I was in charge of the controls that would enable the user to operate the motor. We used a wireless Wii nunchuck. It has a joystick and 2 back buttons. For this application, I wanted to do a circuit that minimized the amount of wires required and the use of resistors in this build. So what I did was I was able to buy a PCB board that connects to the Bluetooth receiver of the Wii nunchuck, and from there all I had to do was solder header pins onto the PCB board and then run wires from the 3.3 volt output from the Arduino as well as the ground, and the only 2 analog pins that I had to connect to the microcontroller were analogs 4 and 5. With those outputs, I was able to control the speed of the motor by simply pushing forward. And there was two other options. While you held the joystick forward and push C, the blue button, you were able to accelerate at a slower rate than normal. But if you push the joystick forward and the red button, you were allowed to accelerate at a much faster rate. Something that I learned in building this project was the ability to install and use different libraries that are available through open source and the Arduino playground. Another thing I learned was that how to correctly debug any sort of electrical mishaps that occurred during the process of the project. And now I'm going to hand it over to Marshall again.
What I learned that was most important during this project was different ways to interface the open source, user-friendly maker community Arduino with products like the electronic speed control used here. Turns out there's almost no paper on it, but all you have to do is give it a PWM signal through the servo pins, and it's simple as that. So the basic functions that we learn from using the Arduino interface with real-world electronics, as simple as that, and that was something that I found was very profound, and I hope to run into more projects like that in the future, where it's a simple solution that can be found. And that's our project. I think we hit all the spots, and this is us.